Hi students, all of you welcome. Welcome to Sunil Engineering Academy. Students, in this session, we are going to practice MCQs on units and dimensions. Okay, so don't skip the video till the end. Coming to the first question, units of density. Units of density. In the theory class of units, I said one important thing. So we have to know the formula of the quantity whatever they have given. So if the force given, density given, pressure given, okay, if we know the formula, we can easily get the units, okay, and we can easily get the numericals, we can easily get the relation, okay. So formula is very important. So if you can consider, don't need of no need of any by hand of units. If we know the formula, we can easily derive. So density formula, mass by volume. Okay, mass is in kg, volume meter cube. So kg per meter cube. So the answer is option A. Okay, so the answer is option A. Coming to the next question. Units of angular acceleration. Units of angular acceleration. If they are asking linear acceleration or just acceleration, if they are asking, acceleration A is equal to dv by dt, change in velocity with respect to time. Velocity meter per second, time second. So meter per second square. It is the linear acceleration or acceleration. If they are asking angular acceleration, when coming to this angular, that meters will be replaced with the radians. So radian per second square. So the answer is option D. Okay, so like that we can easily give the answer. If we know the formula, if we know the concept, easily you can give the answer. No need of any by hand. Okay. The momentum is equal to mass into velocity, correct? Mass into velocity, mass kg, velocity meter per second. Okay, so kg meter per second. So answer is option A. Like that you can easily give the answer. Units of impulse, just I am giving here the learning method of units. Okay, so no need of blindly by head, just follow, just remember the formula, and from that you can easily get the idea. So impulse, what is the impulse? Force in a short duration, short time. So force Newton, time seconds, Newton second. So the answer is option C. Okay, if they are asking the same in CGS unit, then Newton will be replaced with dyne, and second is same. Okay, so dyne second. So like that, if they have not mentioned anything, we can go with the SI unit. Okay, so modulus of elasticity, in the theory class I have given modulus of elasticity. Maybe it may be bulk modulus or rigidity modulus or Young modulus. So whatever it may be. So here the units are same like pressure, force by unit area, or stress by strain. Okay, so generally the formula, if you can consider stress by strain, stress is nothing but force by unit area, strain has no units. Okay, so finally force by unit area, force by unit area in the sense force Newton, area meter square, Newton per meter square. So remember one thing, if you go with the pressure, stress, modulus of elasticity having same units, modulus of elasticity having same units and same dimensional formula. Okay, the units are same, dimensional formula also same. Okay, coming to the next question, units of pressure, just now I have given, if we know the formula, we can easily get the answer, Newton per meter square. So surface tension, force by unit length, force Newton, length meter, so Newton per meter. So answer is option B. Okay, answer is option B. So no need of remember. Okay, I think you got the idea. You got the idea. Coming to the next question, coefficient of viscosity. Coefficient of viscosity denoted with the letter zeta, that is shearing stress by Steering stress by velocity gradient. Velocity gradient. Stress Newton per meter square. Okay, pressure stress same. Velocity gradient dv by dx. dv velocity, change in velocity, meter per second. X distance, meter cancel out, then you will get Newton into second per meter square, or Newton per meter square into second. Newton per meter square can say Pascal second, or Pi's LE, or Pi's. So these are the units of coefficient of viscosity. Newton second per meter square, Pascal second, Pi's LE, or Pi's. Okay. Power of lens, you know very well, diopter. Okay, diopter. If the doctor has prescribed power as plus 2.0 D, what is this plus indication? Just to rotate the plus, you will get X. Okay, if you rotate the plus, you will get X now, that is convex. That is a simple remembering trick. Okay, if they are asking focal length, 1 by power, so 1 by 2, that is 0.5. So that is the focal length. Okay. Refractive index mu is equal to c by v. So c is the speed, meter per second, velocity meter per second. So that means meter per second cancelled out, so it has no units. What is the unit of physical quantity? Jerk. What is meant by jerk? Anyone having idea? Jerk is nothing but change in acceleration. Okay, change in acceleration. So if you can consider, velocity is nothing but change in displacement by time, so meter per second. If you can consider acceleration, a dv by dt, change in velocity with respect to time, meter per second by second, meter per second square. If you can consider jerk, jerk is nothing but change in acceleration with respect to time. Okay, so whenever we suddenly raise the bike, then what will happen? Suddenly rise, that means acceleration we are increasing suddenly. So change in acceleration is nothing but we feel, what we feel suddenly if you rise, then we will feel jerk. Okay, so jerk in the sense meter per second square, acceleration meter per second square, time second, so meter per second cube, so meter per second cube. So the answer is option B. Okay, so if we know the formula, we can easily get the answer. Sir, how many times you told that now, sir? We will follow, we will learn the formula, sir. Okay, please stop it, sir. Huh? You are feeling like that? Okay. If you learn the formula, then I stop saying learn the formula. Okay. What is the unit of relative density? So whenever there is a word relative, so almost it is a ratio. Numerator, denominator same. So whenever the numerator, denominator same means it has no unit. Okay. Units of impedance. Impedance is nothing but it is the opposition in AC supply. Okay, so we have the two types of the supply, DC supply, which we can store, okay, in the batteries. Okay, AC supply we may not store, and AC supply is alternating quantity. Alternating means it is following positive, negative, like that. DC supply means it may be constant, maybe a constant or direct current, you can say. Okay, direct current, you can say. So in our all boards, okay, in your houses you have the meter, electricity meter is there. From that switch boards are there. So all those you have AC supply. Okay, but in case of in mobile, in the mobile, the supply in mobile you are using with the DC supply. There is the battery is there na. So wherever there is a battery, that is a simple idea, DC supply. Okay, so how you can charge the mobile through AC supply? You have one adapter is there na. Adapter converts whatever the AC supply to DC supply. Okay, so in that adapter there is a step down transformer is there. Okay, which converts 240 volts AC supply to required 12 volts or whatever your charger capacity, 12 volts or 5 volts, whatever it may be. Okay, so it reduces that one and converts AC supply to DC supply. Okay, so here one device is there which convert AC to DC. Rectifier is the device which converts AC supply to DC supply. Here inverter is there. In our houses we are using the inverters. Inverter converts DC supply to AC supply, DC. So we are using the battery and battery is connected to one inverter box. Okay, that takes the input supply of battery and converts to AC supply. Okay, so in the impedance is nothing but it is the opposing quantity in AC supply. Okay, so in resistance, if you can consider the resistance, this is the opposing quantity purely in the DC supply. Okay, so but this Z contains both resistance plus reactance. Okay, R is the resistance, X is the reactance. So while considering in AC supply, you will get additionally this reactance concept. If you can consider DC supply, Z is equal to R only. So only resistance we have, no reactance. X is equal to 0. Why? Because in the DC supply, there is no frequently repeated. So that means frequency is 0. X is in the terms of omega L or 2 pi f L. So whenever the frequency is 0, X term is going to be 0. Okay, we don't need this much of concept, but just giving some idea. Okay, all these daily life devices are important for exam point of view, and we have to know in those are useful in our real time also. Okay, so Z is equal to R plus Jx, resistance plus reactance. Resistance units are ohms. Okay, reactance units are ohms, and these impedance units are also ohms. Okay, so try to remember resistance, reactance, and impedance, whatever it may be. Okay, for all those units are ohms. Okay, so if we know some story about the quantity, then it will be easily remember for us. Correct or not? Our mind accept that. Okay, otherwise it may not accept to store or to remember. Okay, what is the physical quantity? Entropy. Entropy. So what is the formula of entropy? That is, entropy is nothing but heat by temperature generally. Okay, so entropy is nothing but heat by temperature. So heat by temperature, heat units are joule, temperature units are Kelvin. So joule per Kelvin. So the answer is option D. Okay, answer is option D. Coming to the next question. Permeability of free space. Permeability of free space. Permeability of free space is mu. So mu units are Henry per meter. Henry per meter. Okay. So the answer is option C. If they are asking permeability of any substance, then also Henry per meter. Okay. If they are asking relative permeability, in that case, relative per mu is equal to mu naught into mu r. If you can consider mu r is equal to mu by mu naught, so it is also Henry per meter. Mu naught Henry per meter, so both will be cancelled out. So then relative, whenever there is a word relative, it has no units. Okay, but they are asking free space mu naught value, that is mu naught units Henry per meter. If you forgot this one, where you have this word mu in inductance, L is equal to mu n square A by L, in that you have the mu word. Okay, so if you want units for mu, capital L is the inductance. Inductance units are Henry, very important. Capacitance units are farad, inductance units are Henry. So L into small l by n square A. So if you can consider number of terms are 1. Okay, L per inductance, that is Henry. Okay, length meter, area meter square. 1 meter getting cancelled out. So you will get Henry per meter is the answer. Okay, so any unit will be derived. Sir, again saying so same thing. Okay, stop it. I am stopping here. Okay, coming to the next one. Units of amount of substance. Amount of substance is nothing but mole. Okay, coming to the next question. Units of electric current, you know very well. Current units are amperes, amps. Okay, and that amperes are measured by ammeter. Measured by ammeter. So coulombs is the unit of charge. Q, Newton, you know very well, force. volts, voltage, potential, voltage difference, potential difference, EMF. For all those, volts is the unit. Potential difference, volts. Resistance, ohms. Frequency, hertz. Okay, don't confuse. Henry is the unit of inductance, denoted with letter L. In the theory class of electricity, I have given in detail about this. Okay. If you are very weak in the physics, try to watch the electricity theory class. If you go with the playlist, then you will surely get the playlist of nearly 24 to 25 videos of physics theory classes. Okay, in that first video, so first four videos belongs to electricity only. Okay, that is a very big topic and very important topic. So farad is the unit of capacitance, and you know very well ampere is the unit of current. Serious units of force, died. Okay, serious units of force is died. SI unit is Newton. Okay, Newton is the SI unit. Electromotive force, EMF. EMF is nothing but open circuit voltage. Open circuit voltage. Okay, if you have one battery, if the battery is not connected to any circuit, that is the EMF that has the, if you measure that one in the open terminals, whatever the voltage you are getting, that is the EMF. Okay, so if that is connected to the load, then across the load terminal, whatever the measurement you are getting, that is the voltage. Okay, so the EMF is nothing but simply you can say gross value. Okay, voltage is nothing but you can say net value. Net value. Okay, so electromotive force, volts. Magnetomotive force, mmf. Mmf is nothing but magnetomotive force. mmf is nothing but uh, number of turns into current. Number of turns into current. Number of turns into current. So current amperes n per turn. So ampere turn. So the answer is option A. Okay. Magnetic flux. Flux Webers. Okay, Weber is the SI unit. If you can consider CGS unit, that is the Maxwell. Okay, 1 Weber is equal to 10 power 8 Maxwell. So Weber is the bigger unit. Maxwell is a small unit. If you can consider 1 Maxwell, 10 power minus 8 Webers. Okay. Magnetic flux density denoted with the letter B. B is equal to flux by unit area. Flux Weber area meter square. So Weber per meter square. Weber per meter square is nothing but 1 Tesla. So Weber per meter square not given. Tesla given. Go with Tesla. Electric field intensity E is equal to voltage by distance or voltage by length. Volt per distance meter. Volt per meter. So the answer is option C. Conductance. Conductance units are Siemens or mho. Conductance denoted with the letter G. Reciprocal of resistance, that is resistance units are ohm. 1 by ohm is nothing but ohm universe, that is nothing but mho. Okay, so to recognize the scientist, we are giving another name for this Siemens. Okay, electrical energy. Energy units are energy is equal to power into time. Power kilowatt, time second or hour. So kilowatt hour. So kilowatt hour is the electrical energy. Remaining all these three are units of electric power. Don't confuse with the power and energy. Electrical power units. Okay. Units of specific resistance. Specific resistance is also called as resistivity. Resistivity denoted with the letter rho. Okay, where we have this rho word in the resistance, rho L by A na. So if you want rho, RA by L. So R is the resistance, ohms. Area meter square, length meter. So meter getting cancelled out. So you will get ohm meter. Ohm meter. Okay, so the answer is option B. Mutual inductance. If they are asking mutual inductance, self inductance, or only inductance, whatever it may be, the units are Henry only. There is no change. Okay. Luminous flux denoted with F R Y. This is lumens. Luminous flux, lumens. Magnetical flux, Weber. Okay. Candela is the luminous intensity, not flux unit. So luminous intensity they are asking, then go with the candela. It is the one of the base unit of SI system. Correct. Units of brightness. Brightness in the sense lumen per meter square or candle per meter square. So the answer is option C. Okay, brightness. Brightness in the sense candle per meter square. That is luminous intensity per unit area. Luminous intensity per unit area. So intensity units are candela, area units are meter square. So candle per meter square. Okay. Light year is the unit of, you know very well, astronomical distance. Astronomical distance. Electron volt, EV. EV is the unit of energy. So many students will give wrong answer. Whenever they see the word volt, potential difference will give. Okay, but here they are not asking only volt, electron volt. The electron volt is the unit of energy. Okay. The value of Planck's constant. Here if you observe, all the values are same. Then what is the difference? Units are different. So we need to calculate, we need to get the units of Planck's constant. Okay. Nu is frequency. So frequency is equal to 1 by time. So if you want H is equal to E by nu. So nu is equal to 1 by T means E into T. E is equal to energy joule times seconds, joule second. Okay, joule second. So the answer is option A. Answer is option A. Dimensional formulas. Now I want to give approximately 10 questions on this dimensional formulas. Then you will get the idea. I have already explained in the theory. Okay. So force we know very well. For mass we denote with the M. So units meters. Okay. So for all the length for all sorry mass M kg. Mass units are okay, r gram length. Sometimes some mistakes are coming. Okay, so length meters, time t seconds. So we mainly denote all the units in this dimensional formulas. Okay, so if you have force, mass into acceleration. So mass we denote with the m, acceleration units are meter per second square. So meter we have denote with the L, second square we have denote with the T. So T square, ml square is the force. Sorry, ml by T square na by second square na by T square. So ml T power minus 2 is the force dimensional formula. So the answer is option A. Okay. So try to remember force directly. Why? Because force is used in so many quantities. Okay, work in terms of force, pressure in terms of force, surface tension in terms of force. Okay, so that's why impulse in terms of force only, force into time. Okay, so all are very important. So try to remember for force, work, force into distance or displacement. Okay, force ml t power minus 2, distance or displacement L, m L square t power minus 2. The answer is option B. Dimensional formula for mechanical power. So power is equal to, you know very well, work by time. So work just now you got na. So what is the work? ml square t power minus 2, t power minus 2 by t. So ml square t power minus 3. The answer is option C. Momentum. Momentum is equal to mass into velocity. So mass m, velocity meter per second, meter length by t means t power minus 1, ml t power minus 1. So the answer is option. Pressure is equal to force by unit area. So force ml t power minus 2, area meter square, so length square. So ml power minus 1 t power minus 2. T power minus 2. So the answer is option A. Surface tension, force by unit length, force M L T power minus 2, length L. So M L power 0, T power minus 2. So the answer is option B. So like that you can write the dimensional formula. Okay. So thermal capacity, heat by temperature. Thermal means heat. Capacity with respect to temperature. So heat is nothing but energy. So energy work almost same, force into distance you will get. So force ml t power minus 2, distance L. So heat you will get ml square t power minus 2, temperature Kelvin. So ml square t power minus 2 k power minus 1. Okay. So here you can simply get the idea, thermal capacity, heat by temperature, not temperature is in the denominator. So K is in the denominator. K comes to the numerator, it will become K minus 1. So the option which are available K minus 1, you can directly go with the that option. Okay. So option C is the correct. No need to derive in detail. Okay. Boltzmann constant, same. Boltzmann constant also same, ml square t minus 2 K minus 1. Same formula. Universal gas constant. Universal gas constant, you know very well, PV is equal to nRT. So here R is equal to PV by NT. If you can consider N is equal to 1 mole. Okay, R mole also given na. Okay, take it. Pressure, force by unit area. Force ml T power minus 2 by unit area. Area is length square. So this is for pressure. Volume length cube. 3 meter cube na L power 3. Mole, temperature Kelvin. Okay, so Kelvin comes to the numerator, K minus 1. K minus 1, only one option, go with option A without any other. Okay, so only one option is there. Na? So if you want, you can calculate L power 1 is there. L square, M L square, T power minus 2, K power minus 1, mole power minus 1. Okay, all of you clear? So coming to the next question. Gravitational constant G is there. Okay, so we know F is equal to G m1 m2 by d square or r square, that is a distance. Okay, G is equal to F into distance square by masses, product of two masses. So force mlt power minus 2, distance square, meter square. Meter square means L square, m square. So m square comes to the numerator, m power minus 2 plus 1, m power minus 1 L power 3, here 1, here 2, 3. So t power minus 2, m power minus 1, L power 3, t power minus 2. So answer is option B. Okay. So remember one thing here, one important question. The term which is having negative mass term, that is a gravitational constant. Negative mass term. Okay. So potential, resistance, here all these discussed in the theory classes. Okay. Now I want to complete the session as soon as possible. So in the following, which are dimensionless quantities already given, strain, relative permeability, refractive index, all. So the answer is option D. The physical quantities having only units without any dimensional formulas. These two don't have dimensional formulas. The following which quantities having same dimensional formula. So if you can consider all this, force and energy no, work force no, momentum and impulse yes, they have same dimensional formula. Which quantities having same dimensional formula? Here work energy, yes, having same dimensional formula, same units joules. So the answer is option B. Okay. And again same dimensional formula they are asking. Stress, strain no, strain has no units. Work, power no. Pressure and stress, yes, they have same dimensional formula, same units. Which quantities having same dimensional formula? Again speed and velocity, yes, same. Work and torque also, yes, same. So the answer is option C. Okay, work is equal to force into distance. The same way torque is also force into angular velocity or angular distance. So almost same you will get. Okay, here work Newton meter, this one also Newton meter. So Newton meter is considered as joule. So generally we go with joule for work, Newton meter for torque. Okay, which quantities have negative mass? Just I have given gravitational constant G, capital G. Okay, so we have completed the questions on this units and dimension. Okay, and students, if you really like my sessions, don't forget click on like option. Okay, click on like option. And if you want to download the PDF, you can visit the sunilengineeringacademy.com, and I will also give the link of 1 minute video how to download the PDF. Okay, so I will post that in the comment section and in the description box. Watch that 1 minute video, then you will get the idea. Okay, how to download, and after that, that is where it will be available. Okay. Okay, students, okay, students, thank you so much for watching. Take care. Bye, guys.